Jai Hind to everyone. My name is Pooja Pandey, Assistant Professor in the MCA Department in AKG College. And today my lecture tutorial is on the input-output processor, that is you can say IOP. That is according to the AKTU syllabus, it is in the unit 5 in the computer architecture and the organization. The code is BMC 105. So what I am going to cover this topic are the input-output processor, that what do you mean by the IOP, what is the block diagram of the IOP, then we will quickly discuss the flow chart, its features, its advantages and the disadvantages. So let's start our presentation, that what do you mean by the IOP. See, IOP, you can say we have in the previous, we have already discussed that data transfer, right? There are three types of the data transfer, that is program input output, interrupt initiated input output and the direct memory access, right? So in previous three, we see that the CPU is working some way or the other way, the CPU is working. So we want that our CPU should be free. So you can say that input output processor or IOP is a processor with direct memory access capability. It means that it is similar to the CPU. You can say it is similar to the CPU, but it is not. It is CPU, but its working is like the CPU because it is, but it only handles the details of the input output processor. That is, the IOP is very similar to the CPU, but it doesn't work like the CPU, that it is managing the whole thing. The IOP work is that it is only handling the details of the input output processing. So it means that IOP can fetch and executes its own instruction. It is not dependent upon the other portion, that that it has to take the permission from the CPU, or it has to take the permission from the memory. So input output or IOP main work is that it is taking the control, or it is managing the input output task only, right? So it has got the separate division, that input IOP is working only on the input output task, nothing else it has to do. So we can say that it is acting like the CPU, but it is not the CPU because it is only handling the details of the input output processor. Now, the IOP can fetch and executes its own instruction. It don't have to take the permission from the CPU. Now, the IOP instructions are designed to manage the input output transfers only, right? So what do you mean by the input output processor? Input output processor is a processor with the direct memory access capability. Then second thing, that it is acting as a similar like the CPU, but it is only handling the details of the input output processing, right? Now the third point is that the IOP can fetch and execute its own instruction, right? And it is designed only for the input output transfers only. Now, when we are discussing about the block diagram, clearly you see that here it is CPU, here it is IOP, here the several peripheral devices are there, here is a memory unit, and this whole thing is connected with the help of the memory bus. Now, this memory is occupying the central position, and it is, you can say, it is if I am saying that memory is occupying the central position, and it can communicate with each processor by the direct memory access, right? Now CPU is responsible, this CPU, you see that this CPU, it is responsible for the processing the data. Now this IOP provides a data path, you can say it provides a path for the transfer of data between the various peripheral devices and this memory. So memory, whenever memory want to communicate with the other peripheral devices, it has to communicate with this IOP, you say. It will communicate with the IOP, right? Not with this. So this is a main, it is acting like a CPU, right? Now, if you are saying that, now this instructions, you see that this instructions we are reading, whatever the instruction we are reading from the memory, they are by the IOP. Whenever the instruction are read by the IOP from the memory, it is called the commands. Okay, we say the term it as a command, and it is distinguished from the instructions that are read by the CPU. So this is a block diagram of your, you can say, that is a input output processor. Now when we are discussing about the CPU and IOP communication, then how it is works. So you can see that this is a CPU operation, this is a IOP operation. Here the CPU operation, whatever the CPU operation, CPU first sends in instructions to check the input output of path, whether it is ready or not. Now when it is ready, it transfers the status word to the memory location. For example, if you remember the diagram, right here it is a memory, here it is CPU, here it is, you can say, here it is IOP, right, and here it is connected like this, if you remember this diagram. Now if instruction, CPU is sending the instruction to the IOP path, this IOP, what IOP is doing, it is transferring the status word to the memory location, and if CPU is sending the message that okay, the status is okay, then the instruction, this IOP will start performing its instruction. Now after performing the instruction, right, this start IOP input output instruction to the IOP, it means that he is sending the message that you start the input output instruction, right. Now this what, and after this, here from CPU it is sending the message. Now it is coming it is accessing the memory for the input output program, because it is fetching the data which should be done, right. Now it will conduct, here it will conduct the all the, you can say, all the input output transfer, or it will prepare the report, and when this input output transfer is completed, the CPU is interrupted, right. Now this, it is said, this when the input output transfer is completed, the CPU, this input output send a request to the CPU that whatever the current status of the IOP is there. So when it is, this request has been sent, and now it is again, it is sending the status word, its you can say its position to the IOP from the memory location. Now this, it is again, we are sending it to the check the status word for the correct transfer, and whole this process is continue until we are doing. So this is a communication between the CPU and the input output processor. Now what are the features of, you can say, the input output processor? First one is the specialized hardware, right. Why it is a specialized hardware? Because this input output ports, you can say, it is equipped with the optimized hardware like the input output ports, DMA controller, which is an interface between the DMA and the input output. When we are studying the DMA in the previous lecture, we have seen that it is a very important part in the architecture, right. Now this interrupt controller, all these are the specialized hardware that is equipped with the input output ports. Now DMA capability, see, this IOP has a direct memory access capability, because it directly transfers the data between the memory and the peripheral, and it is freeing the CPU from this. With the help of the input output, the pressure of the CPU has become very you can say very less, so that's why it is increasing, it has a DMA capability. Now interrupt handling, it manages the interrupts from the peripheral independently, because the CPU is only focusing on now on the application execution. The IOP main work is the you can say it is taking the whole as a input output task, the whole task operations which are performing, it is under the IOP. So it manages, it also manages the interrupts whatever occurring in the other peripheral devices. Now it also supports the protocol. Now protocol handling is also used. For example, the Ethernet, USB, whatever the interface devices or whatever the you can say protocols we are using, the input output processor is supporting. We are not taking any support, or without the extra CPU support, the input output processor by itself is using this protocols, and it is handling this protocol. Now again, the most important thing what IOP is doing is that it is buffering. There is a buffer between the CPU and the peripherals, right? So enabling the efficient handling the large data volumes without the overloading either side, right? So this buffer is also an important feature of the IOP. Now the process commands from the peripherals, and it is reducing the CPU workload. So that is why the command processing is also an important feature of the IOP. Now, as input output operation as the CPU task is performing, parallelly the input output operations are also performing without the hindering or without making any overload on the CPU. So it is also improving the performance and the multitasking efficiency. So we can say that the parallel processing is also a feature of the input output processing, right? Now, what are the advantages of the IOP? We are discussing the first most advantages is it is reducing the processor workload because CPU is not using. So we can say that within IOP, IO processor, the main processor does not have to deal with the input output operation, because we have given a separate department to the IOP that now you have to handle all these things, and because of this it is reducing the processor workload. Now, since the IOP is only concentrating upon the you can say input output operations, so it can directly access the memory, and the data transfer between the input output devices and the memory, it is faster and efficient than with the other method, because the first criteria is that it is accessing the memory directly, so speed is also increase. So that we say, in short, we are saying that it is a improved data transfer rates. Now, another advantages of this that is increase the system reliability, because input output task has all the input output task has got the separate, or you can say the dedicated processor by which our systems are the more fault tolerant. That is, for example, if our input output operation fails, it will not affect the other processors, or you can say other process of the system, right? If one department is failed, other departments are not you can say they are not affected. The same thing is that it is increased system reliability. Now, when we are discussing about the scalability, it means that input output processor system can be designed to scale easily, allowing for the additional input output processors to be needed. If we want to add more input devices, we can add it without the breaking our work, or mainly, and this scalability is very useful when we are particularly we are dealing with the large scale data or the environment where the input output devices can be add on at time to time as per the requirement. Now it is, and if it is a scalability feature is there, then also the flexibility is also there, because we can add many more input devices in between, and we can provide the more flexibility in the system design and allowing better customization for our systems, right? So these are the advantages of the input output processor, that is reduced processor workload, improved data transfer, increased system reliability, scalability, and the flexibility. So these are the major advantages of the input output processor. Now, when we are discussing about the input output processor, anything which is more cost is taking, that is not a good thing for the system. That is the cost. Input output processor, we simply say that we are adding the more processor, but that processor is requiring the additional hardware, or you can say the complexity is required. So there the cost matters. So whatever the system which is taking more cost or more money, it's not a good thing. So that is a major disadvantages of the input output processor. Since we are increasing the input output, more input output processors, so the design will be more difficult. It is more difficult to understand. So we can say that increased complexity can make harder to diagnose or the troubleshoot disease. As much as we are increasing the processor, our design is becoming, we are unable to diagnose if any problem arises in the hardware. We are unable to identify that problem, or we are unable to troubleshoot that issues. So that is a major disadvantages of the IOP. Now again the third disadvantage is that limited performance gains. When input output processors can improve the performance of the offloading input output task, the gain may not be successful. It slow down the speed of the IOP IO processor, right? Now there is a synchronization issues was also there. That is another disadvantages of the IOP. When we are discussing about, when we are attaching the when we are, you can say, when we are attaching more and more processors in the system, and with the multiple processor accessing at the same time, the synchronization issues can be there. Why? Because there is a complexity in the design, and we are unable to find out the errors or the anything or we are unable to find out the solution for it because of this complexity. So there should be the synchronization problem will be arising. Now when we are dealing with the different IO processor architecture, and since there are many different IO processor architecture and interfaces are available, which is you can say it makes unable, it makes it difficult to develop the standardized software and the hardware solution, because we are using the different IO processor. So we are unable to maintain the standards for that, for finding out the solutions, or you can say the software. That's why it is a lack of standardization. That's why it is another disadvantages of the IOP. Now in this presentation or in this lecture, we have discussed that what do you mean by the input output processor, what is the role of the input output processor. Then again we have discussed its block diagram of the input output processor, how it is attached to the memory, how it is attached to the CPU, and how the data is traveling through the memory. It is accessing directly memory. That's why it is a major advantages. Then we have again discussed this application of the IOP. We have also discussed the advantages and the disadvantages in this lecture. So thank you all, and we will meet in the next presentation. Thank you.